so let's put it all together. Let's look at this problem. List the values of N, L, and ML for each of the orbitals in a 4D subshell. So what am I looking for? I want N, L, and ML. What did they tell me? They told me it was a 4D. That's all I know. So now let's talk about what this means. So when we introduced the quantum numbers, I talked about what this format looks like. So this first number right here represents the N. So I know that my N is whatever goes in front of my letter. So the N is equal to 4. Now I know it's a d orbital. So if I know it's a d orbital, I know it's always a what? So remember, if I go back, whoops. If I go back to my d orbital, I know what the L always is. Because if it's a d, my L is always a 2. So since it's a d orbital, I know that my L is equal to 2. Okay? Then I want the ML. And we could just figure out the ML because we know it's negative L all the way to positive L. So my ML would be negative 2, negative 1, 0, positive 1, positive 2. Okay? And that's it. So we're starting to see this little subshell, the NL notation. This is going to be really important because it tells me where those electrons are going to be located. All right? The last thing we're going to talk about in this chapter is the energies. So now that we know this little subshell, we want to be able to say, well, how does this subshell relate to other subshells in energy? Because we talked about absorbing energy, releasing energy, all of that. So here's kind of my listing of my subshells. So let's look over this. So the first thing we should know is that the energy here, here's a 1s, is less than the 2s. But the 2s is equal to the 2p, which is less than the 3s, 3p, 3d. So if you notice, the s, p, and d are equal if the n is the same. Okay? What really makes a difference in the energy is the n, because the difference between this guy and this guy is the n. So energies of orbitals depend only on the value of the principal quantum number, my n. So energies of the orbitals depend only on the value of the principal quantum number. So my energy increases as my n increases. So n equals 1 is lower energy than n equals 2, which is lower than 3, which is lower than 4. The L doesn't make a difference. So if I'm talking about the same n, what orbital I'm in is the same energy. What matters is the n. The higher the n, the higher the energy. So that's why we go all the way back. Let me find it. Here, this was increase in energy. And n equals 1 is lower than n equals 2, which is lower than n equals 3. So now we talked about n's in Rydberg equation. Those n's relate to the same n's as those principal quantum numbers. It all kind of ties together. All right, so that's the end of this chapter. Next lecture, we're going to start chapter 3. Chapter 3 is our trends. And one of the trends we're going to talk about is writing my full address. So we talked about electron configurations a little bit. I used the word, but I didn't tell you how we're doing that. So far, we've talked about our quantum numbers. We've put some of the quantum numbers together, like my N and my L, to get like a 4D or a 2S. But we need to write the whole address. So I need to be able to write the whole address of every single electron. And that's one of the things we'll talk about in the next chapter.